Okay. Good evening, guys. Okay. I think you can hear me. Welcome again. So, how was your week? Last week? How was your week? Is it good? അതായത് സത്യ one second. Let me set up the speaker. Okay. Okay. So, I think the last week was great. Padaring dari dia sati, tu. So, actually, did you guys receive the tunes? You mean? Okay, I have posted the table. Okay, I think I will receive them by tomorrow. Tomorrow, I think by Wednesday. Okay, but I think you will get the tables on tomorrow, Monday, because yesterday and today was holidays. No? That's right. And the other thing is, I told you there are several questions on the tables, so you have to do that one. And also, last week I have given you several questions, homeworks. Did you guys do that one? So actually in the last week, we discussed about the number system conversion to what? 8, 8 mean octal to hexadecimal, no? Octal to hexadecimal and also hexadecimal to octal. So I have given you the homeworks in those two conversions, no? Conversions. Before that, we have discussed several conversions. We have done several works inside our class, no? Okay, so first of all, let's discuss those things. Okay, let's discuss the homeworks and then we will move to the next part. Next part means the last part in our lesson. So that will be coding system. Okay, coding system is the last part. Coding system තමයි අන්තිම ටික. ඉතින් අපි ඒක discuss කරමු. Okay. So okay. So first let's discuss octal to hexadecimal. Octal to hexadecimal sections. Octal. Is this visible? No. Let's see. Here. Octal to hexadecimal. So, what are the homeworks? What are the numbers I have given you? Octal numbers 42. So, let's discuss. Number 1, 42 is in octal base. Okay, let's see. So, in last week, I have told you octal and hexadecimal means they are like octal and hexadecimal. They are like fighting, no? They don't talk each other directly. They are like a fighting couple, no? They like each other, but they don't talk to each other. So that's why we have a friend, common friend, 2, who means base 2, binary. Okay? So if the octal want to talk with hexadecimal, so he need to go through binary. The letter is given to the binary, and then binary is going to deliver that letter to hexadecimal. Likewise, what common friend? So likewise, if you want to convert hexadecimal to octal, the same method. There are no shortcut. Okay, So hexadecimal also do not contact directly with octal. So same procedure. She need to deliver the letter to the binary, and then binary will deliver to the octal. That is the procedure. So here we have the octal number. So the first task is to convert that one into what? Binary. Okay. And I told you what is the connection between binary and octal. What is the connection? So 8 means 2 to the power 3, no? 2 to the power 3 is equal to 8. 8 to the power 1. We can say 8 to the power 1. It is also 8. No? So here, this is the connection. So actually, that means we can use 3 bits of binary, 3 to represent 1 bit of octal. 1 bit of octal. Okay. Actually, when we talk about octal, one number is called as not bit. What? Digit. Okay. We calling the number of this octal and other every number system. One symbol is called as digit. But when we come to the binary, in binary, one symbol is called as bit, binary digit. I think you can remember those things. This is a binary digit, but here they are calling that one as digit, only digit. Okay. So this is the connection between binary and octal. So when we talk about binary and hexadecimal, same, no? When we talk about binary and hexadecimal, so binary is equal, would be equal to hexadecimal. What? 2 to the power 4. 2 to the power 4 is equal 16. Okay. Same theory. That means here we have binary. We can use binary 4 bits. Okay. Binary 4 bits to represent hexadecimal 1 digit. That is the basic theory of conversion to these things. So let's do this first one. So here we have 42. 42 means octal. Okay, octal. That means we have two digits. No, here 4 is 1 digit and 2 is 1 digit. Here, as I told you, in octal number system, we can use 3 bits to represent 1 bit, 1 digit. Okay? That means, so as the first one, we are going to just separate these things. So we are going to keep some space because 1 digit is going to expand to 3 bits. That's right. Okay. So 4. What is the 4? Binary form of 4. You can easily get that by dividing 2. Okay. Here 2. Again 2, 1 and 0. Okay. This is the binary form of number 4. Okay. Likewise, you have to convert those things. So I'm not going to convert this one also. Okay. So if you have a question regarding this number 4 is converted into this 100 or as 100, this is the method. You have to just convert the number to binary like as normal decimal number, decimal conversion. In decimal to binary conversion, we are going to just divide the decimal number by 2 and keep the reminders. And then at the last, we are going to just write the reminders from the bottom to the top. Okay, that is the procedure. I think you can understand. You have your memories, no? I think you can remember that. So here, when we talk about number 2, it is like number 2. Let's see, number 2 is like this, no, guys? 1 and 0. Okay. Number 2 is equal to 1 and 0. But here, so if I write 1 and 0, is it correct? No, because actually this is only 2 bits. So you have to input 1 bit again in the front. So this is the number. So then we can write this number again by connecting all 6 bits. Okay. Then what is the next one? The next one, binary into hexadecimal. Binary into hexadecimal. You can see hexadecimal 1 digit can write by binary 4 bits. So that means we are going to divide this again by 4 bits. We are going to start from the right side only. 4 bits. If the last one doesn't have 4 bits, you can just input, just write 0. Again, we are going to convert this binary number to hexadecimal. Okay, binary to hexadecimal. I think you know the procedure. So I'm just going to write the values. So here we have 4. Here we have again 4. 44 is the answer. No? 50. Is this correct? This is okay, no? This is the procedure. So actually for the first homework, again I have told you the procedure. What happened? Yes, here I have miscarriage. Here it should be right. 100 0 1 0. Okay. So here I can just divide by 4 bit. So then this will be 2. This will be 2. 22. What happened earlier? I think I just write 100 and 100, no? Yes, 100 and 100. It is incorrect. 22 is the hexadecimal number. Okay, it's good, no? Let's move to the second one. What is the second one? 434. 434. Okay, I will just write the answer. Okay, I'm not going to teach you again the method. So here we can just keep some space and write these things again. So here 4 means 1 0 0, 3 means 0 1 1, 4 means again 1 0 0. So then I am going to just divide by 4 bits. Okay. So then I'm going to write the values. Here we have 1. Here we have 1 again 1. Here, what is the value? Actually, I told you in this case, you can just write 10 10, or else 1 0 1 0 means number 10. Oh, okay, number 10, or else I just write 10, or it num A. Then is B, C, D, E, F. Those are the numbers. So you can just convert this one into decimal. So if you convert this one into decimal, 1 1 0 0. So here 1 2 4 and 8. Okay. So here the value will be 8 plus 4 is 12. Okay. So you have to just write the symbol for 12. 12 is the value. You have to just write the symbol. What are the symbols? To 10, we have A. 11, we have B. 12, we have C. 13, we have D. 14, we have E. 15, we have F. Those are the symbols for the values. Okay. So here, 12 is the C. So then the last value will be 106. This is the good, no? Yes, correct. Okay, next one. What is the next one? What is the okay, that is a long one, no? That done. So 11,467, no? Okay, this is in a bit. Let's write 11, 4, 6, 7. Okay. So 7 means 1, 1, 1. 6 means 1, 1, 0. 4 means 1, 0, 0. 1 means 0, 0, 1. Again 1, 0, 0, 1. Okay. So then I'm going to again divide by 4 bits. Okay. So then the answer will be here it will be 1, here 3, 3, 7. 1,337 is the answer. Is it correct? Is it so? Okay, no? Okay. Why? It is very easy. The number is long. Number is long, but the method is easy. So in the previous cases, we have to just divide or multiply, or we have to do several things. Okay. So in that case, if we have a long number, it is very difficult. But in here, actually, you have to just write the value for each digit. It is very simple. Okay. So that's why I have given you a very long number. But this is the value. This is the converted value in 16. I mean hexadecimal. Okay. So any other homeworks in this one? Oh, no. What is that one? 361. Is this one or else octal to 361 is what? Octal to hexadecimal or hexadecimal to octal? This one, no? Octal to hex. I write in here 361. Number 4. 351. So again, we are going to here actually, guys, you have to put the base. Okay, you have to put the base. So otherwise, the answer will be incorrect. Okay, here, make sure you are going to put the base. Otherwise, you will not get marks. Sorry. So keep that on mind. So here 3, 6, 1. So 3 means 0, 1, 1. Here 6 means 1, 1, 0. 1 means 0, 0, 1. Okay. So then I'm going to divide this by 4 bit. Okay. So here we will have 1. Here this is F. Here we have 0. We just don't need to write 0. F1. 15B. F1, like the car is. Formula 1. Okay, this is the last one. Yeah? I think this is the last one. Or else, is there any other uh, numbers in this one? Octal hexadecimal? No, no. Okay. This is the last one. So check the values, check the answers. Okay, and if there are anything, just write the values. Okay. So let's do the other conversion, other homeworks. Just write these things. Is this okay? Just write. Okay, no? Altaf? Okay. Okay, no? Right. So let's move to the next part. I'm going to clean this up. Next part means next homeworks. Okay? The other homeworks. What are the other homeworks? Hexadecimal to octal. Okay? We're going to convert hexadecimal into octal. Oh, I'm going to keep these things. So because let's keep those things. Hexadecimal octal. What is the first one? Number one. What is that's 32. Okay, we have 32 in 16 days. So then, what is the first step? First step is we have to convert this one into what? Binary. Binary. That means, as I told you, one digit in hexadecimal can be written as 4 bits in binary. That means here you can see there are two digits, 3 and 2. So we are going to write these two digits in 4 bits. So 2 means 1, 0. But here only 2 bits. We are going to add another 2 bits. 3 means 1, 1. Again, as previous, we have to add 2 bits. Okay. So then, this is the binary form. Okay. So we are going to convert that binary form into octal. So as previous, 3 groups, 3 bits groups. So here 3, here 3. So then here we have 0. Then here we have 6. Here we have 2. Answer will be 62. 8 base. Okay. Is this correct? Good. Good. So next up, number 2. I think in this one also I have given 5 homeworks. 500, no? 100. This is a simple one. 100 is very, very simple. So I'm going to write 100 in like this. So here 1 means 0, 0, 0, 1. 0 means 0, 0, 0, 0. Again 0 means 0, 0, 0, 0. Okay, you have to write 4 bits. Okay. So then, oh, so then we are going to divide this one. 3, 3, 3, 3. So 400, no? This is 0, 4, 0, 0. Value will be 408 base. Okay. Next time. That is next time. F2. F2 like a function key. I have given you a function key to convert. F2. This is in 16 base. So we are going to just keep a space and write this one again, F and 2. So 2 means 1 0, but we are going to add 2 more zeros. F means 4 ones. Okay, 4 ones. Here you can see. If you want to just convert this one, you have to check what is the value of F. Okay, if you want to convert in normal way, you have to check what is the value of F. F means 15. Okay, so then you know 15 is the value. So then 15 should be converted into binary. Same procedure, you have to just divide. Here 7, 3, 1 and 1. 4 ones will become. Okay, that is the normal way. Just I'm just writing the answer. Okay, you have to just you have to if not writing this way. Calculate. So I'm going to divide by 3 groups. Okay. So for the last group, we don't have 3 bits. So I'm going to just input 1 0. This is not necessary. Okay. This is not necessary, but it is good. අවශ්‍යම නැහැ, අවුලක් නැහැ. දැන් මගේ චිකන් නැහැ. Okay. This is number 2. This is number 6. This is again 3. 362 in 8 base. Okay. Next problem. This is next problem. ICA. Oh, not I know, 1 CA. 1 CA. This is in hexadecimal. So let's write the answers. 1 CA. So 1 means 0, 0, 0, 1. C means what? 1, 1, 0, 0. Okay. So A means 1, 0, 1, 0. This is for these digits. So then I'm going to write. I'm going to divide for 3 bit. Okay. So what are the values? Here we have number 2. Here we have number 1. Here this is number 7. This is 0. Okay. 712 is the answer. Correct? Okay, no? Is there any other numbers? Other questions? No. Okay, those are all the homeworks, I think. Is all the questions are correct? Homeworks? Is all the things are correct? Good, very good. Altaf, what about you? Okay. So what is the incorrect one? In this case or previous case? Did you notice the mistake? This number 3, this one. Did you notice the mistake? Is this correct? Is this okay now? Okay, good. Okay, those are the conversions, guys. Okay, so actually, students, so you will have one conversion, 1 or 2 conversions in your all-level paper, but when it comes to the second term or first term, I think the first term is finished now. When it comes to the second term, you will have several questions, sorry, because up to second term you will have finish only 5 or 6 lessons. Okay, in that 6 lessons you need to write whole paper. So in that case you will have several conversions in the term test. Okay, just be practice for the term test. Let's move to the next part. Okay. Oh, first chapter me still in the first lesson. තාම පළවෙනි පාඩමේ ඉන්නේ. Oh. So actually, I thought you have in like second lesson or something. But it's good, okay? I think it's okay. But I didn't do the second lesson. No, I didn't do the second lesson. I will send you the tunes on the next uh, for the next lesson. Okay. Actually, for the next lesson also, for grade 10, you didn't do anything. Is it because sport meets? No, sport meet in. And what about Altaf? What is you are in okay, Altaf is okay, but with so what about the first term test? Did you got any paper? Paper have come down. So what are the questions included in the paper? Only the first one or in the ninth grade sections? Hmm? Okay. So Aldaf, you can also just send him a message not directly, okay? Because when you send the message directly, I have to just change the chat box, okay? So it is no conflicts. So just send the message for the as everyone. Okay? It is more easy. Okay. So so let's move to the next part. What what is the next part? Number system. No, not number system. Coding system. Okay. What happened? I think I have allowed you to just check whether you can change into the main chat. If it is possible, it's okay. But let's see. I can open this on new tab. No, I can't. Just okay. No. You give me 1 minute. Okay. Okay. So let's move to the next part. So the next part is coding system. Okay. So actually we can finish our lesson today. I think we can finish our lesson. So let's move coding system. Okay. So the next part is coding system. Coding system. And This is a very important part because you will have a one question, one or two question, or it's like one question for the O-level exam, and it can be included into MCQ or the second part. Okay, most probably for the MCQ. Okay, you will have one question in coding system, one or two questions. Okay, that means 2 marks. So 1 marks is also very important. So keep in mind that. Okay, what is a coding system? Okay. You know the name coding system. Okay. What is mean by coding system? Why do we need a coding system? Okay. So I told you our computer can only understand ones and zero. No? Computer can only understand ones and zero. What is the language for ones and zero? That is called machine language. No? Machine language. Okay, machine language is the machine language, but binary is also ones and zero. Okay, so that's why we told you in the previous stage, computer can only understand binary. Okay, binary means, guys, machine language. Okay? So the computer can understand only machine language. So here I will write, I draw a computer. Here we have a computer. So this guy can understand only ones and zero. Okay. So if we are going to input something, what is the input device we are going to use? Is keyboard. Okay, keyboard. So here escape button. Here we have function. Like this is the keyboard. This is the keyboard. Okay. So when we want to insert some key to the keyboard, okay, what is the procedure? What is the procedure? So you will think we are going to press character A. Okay, you will press character A, and the character A will be displayed in the display. No, normal way we are going to press character A. Okay, so then that word will be displayed in the display. So actually, when we press A will not flow through this wire. That means the character A will not flow from this side because the A character cannot be understood by the computer. No, A means it is like a drawing. I told you, computer cannot understand any character. They are like drawings. Okay. So if we press A, computer can't understand the simple meaning of A. So for that one, what we are going to do, what the keyboard is going to do is, they are going to deliver some digital signal. Okay, it is like ones and zero. Likewise this. Okay, likewise ones and zero. When we press A, ones and zero will be moved through this wire. Okay, so then when this number or else this this number is go to the computer should understand this one. No? That means he can understand this one, but he don't know what is the value of this one. Okay, he know the ones and zero. He know the ones and zero, but they don't know the value of this one. Okay? That means in the computer, we are going to give several instruction. Okay, we are going to give several instruction. If you got 1 0 1 1 0 1, you can display this character. Okay, if you got 1 0 1 1 1 0, you can display this character. This is like a picture. Okay, for the computer, this is like a picture. They don't know the meaning of these things, but they do know the meaning of these things. These two they can understand, but they don't know this one. Okay, likewise, when we press something, some message will be delivered to the computer, and then the computer going to check that instruction. That instruction, what is the sim number and what is the symbol. And then according to this instruction, they are going to display the symbol. That is the method, guys. When we press some key in our keyboard, that is the method to display that key. Okay. Likewise, I told you here we have given some instruction. Okay. Those instructions are called as numbers coding system. Okay. Those instructions are called as coding system. Okay. That means there are several systems. There can be several systems. Okay. So as example, I'm going to write this instruction. Okay. Those are several instructions. I'm going to write this instruction. So my preference is, if you got 1101, just display A. If you got 1110, just display B. Because those are my preference. My instruction set is this one. Okay, my. So let's see, UMIT. UMIT is also going to insert several instructions. So UMIT don't like this number. So UMIT is going to do 111011 is should be displayed as A. 1100 should be displayed as B. Likewise, UMIT is going to insert a different instruction set. This is like one coding system. This is like another coding system. Altogether, we are calling those things as coding systems. Okay? That is the meaning of coding system, and that's why we are going to use coding system. To input numbers or characters. So input anything on a keyboard, only keyboard. If we are going to input something on a keyboard, computer cannot understand the signal. So in that case, we are going to give several instruction sets. Okay, those are like coding instruction sets. Those are the coding system. Okay, did you guys understand the coding system? Okay, good. So let's write this one, and let's talk about the coding system. I will just write those things also. Okay. So here, like I told you, there are two different coding systems. Okay. Likewise, we are going to learn 4 different coding systems in our computer system. Okay, we are going to learn 4 different coding systems. Okay. So first one is BCD. That means binary coded decimal. Okay, this is the first coding system name. Okay, second one is ASCII. This is a little bit large, long name. Okay, American Standard Code for Information Interchange. Okay, that is the name, ASCII. Okay. Third one, EBCDIC, Extended Binary Coded Decimal. What is that? Interchange code. Interchange code. That is the third one. And the last one is Unicode. This is the last one. Likewise, there are 4 different coding systems. Okay, we are going to learn about these 4 coding system. Okay, let's write. Just put the topic coding system used in computers. Coding systems used in computers. Coding system used in computers. Okay. Right? When data is entered into a computer, when data is entered into a computer, comma, it is converted to it is converted to binary digits. It is converted to binary digits 0 and 1 as machine language. As machine language. Accordingly, no, all data entered from the keyboard. Accordingly, all data entered from the keyboard are stored in storage devices using binary codes. Those are called as coding systems. Those are called as coding systems. Those are called as coding systems. Next point or next bullet. Various coding systems have been developed. Just put number 1, 2, 3, 4 and write these things. Is this visible? Can you guys read these letters? Okay, no? Okay, good. Just write these things. BCD, ASCII, EBCDIC, and Unicode. Those are coding systems. And if you want to draw this one also, you can just draw this one. And once you finish, just raise your hand. Okay. Okay, now give me 1 minute. I have to refill the pen. Okay. So let's move to the first one. Right? First one is binary coded decimal. So I am going to clear all these things. First, we are going to learn about binary coded decimal. There is a easiest one. Okay? This is the easiest one. Binary coded decimal. So the meaning is inside in the name. Binary coded decimal. Okay? That means we are going to code decimal into binary. That is simple as it is. Okay? So actually, guys, in this coding system, we can represent only numbers. Okay, we can represent only numbers in this using BCD, or else binary coded decimal. Okay, so that means when we write a number, okay, when we are going to write a number, so number is like decimal value, no? Decimal characters 1, 2, 6. Likewise, we have a decimal characters in a decimal number. Okay, what is binary coded decimal? We are going to code each character by binary. Okay, we are going to represent each character by binary. And how many bits we are going to use? That is a question, no? So when we are going to represent 1, we can just 0. 0 can be represented as 0. 1 means 0, 1. Okay, 2 means 1, 0. Likewise, we can use several bits, no? We can use several bits. But when we are using coding system, guys, there is a specific bits numbers. Okay, that means there should be a specific number of bits when we are using coding system. What is that specific number in the BCD? BCD. Okay, let's say. So in any number, we have numbers or characters from 0 to 9. We have any number from 0 to 9. Okay, you know that one. So if we write any number, that number will include characters within 0 to 9 range. Okay. So we are going to get the large number, largest character. Largest character is 9. No? Largest character is 9, number 9. So how many bits we want to write the number 9? If we are going to convert that one to binary, 2, there will be 4, 1, 0, 1 and 0. 9 is equal to 1, 0, 0, 1 in binary form. Okay, you can see if we want to represent the largest number in binary form, we need 4 bits. Okay, so in that case, we are going to use 4 bits for each and every number, each and every digit. Okay, that's why we are going to use 4 bits for every digit. Okay, 0, we just can't represent 0 like this. We have to use 4 bits, 4 zeros. Okay, because every number should have unique number of bits, same number of bits. So 1 should be represented as 0001. 2 should be 0010. Okay. Likewise, number 9 is the largest one. It should be 1001. Likewise, every number or every digit should be represented as 4 bits. Okay. In 4 bits. Do you guys understand that? Okay. Okay, no? Good. Let's write one number. I'm going to write one number. So where shall I begin? Okay. I'm going to write in here. The number is first one 123. No, 120. 120 is the number. So I'm going to represent this number using BCD. Okay. Always remember, we can represent only numbers using BCD. Okay. If there is a character like go or as just any word, okay, home, we can't just represent home as BCD. We can only represent numbers. So just remember that one. So we have 120. That means we have 1, 2, and 0. So we have to use 4 bits for each character. 1 is, like, I am going to write in here. 1 is like 0001. Okay. 2 is like 0010. 0 is like 0000. Okay. So in this case, guys, we can't just erase the first 3 bits. Okay. This is a coding system, not a value. Okay. When we talk about values, if we have a number like this, we can just erase the first 3 bits, no? First 3 zeros, because it is a value. But here, this is a coding system. Okay. In that case, we can't just erase the front zeros. Okay. So here actually we have to just write BCD. This is how we can represent a number using BCD. Okay. This is how we are going to represent. So let's write another one. I will give you one question. So write for the what? 431. Write for this one. Okay, just wait. Let's let's write this one. First, let's write, and then we can do the works. Okay. Before that one, I'm going to I have to explain several things again. So here we are going to use 4 bits. No? Okay. For one character, we are going to use 4 bits. So that means there can be a maximum number of characters. Okay, there should be a maximum number of characters when we are using 4 bits. What is the maximum number of characters? We are going to use 1s and 0. We are going to use 1s and 0 for the coding system. So in that case, the number is 2, or its base is 2. And we are going to use what? 4 bits. That means the power number is 4. So then, how many characters or else how many values we can represent? 16. Okay. Actually, in the BCD or as binary coded decimal, we can represent 16 values or as 16 numbers using BCD. Okay. But we are going to use only 10. Okay. We are going to use only 10. The maximum is number 9. We are not going to use number 10 or number 11. Likewise, all 16 characters will not use in this one. Okay. We are going to use only first 10 characters. Okay. First 10 values. Got that? Okay, no? So if there is a question, how many characters we can represent using BCD, you have to just write like 16. Okay. But when we are going to write using BCD, we are not going to write more than this one, no? More than 1 0 1 0 and 1 1 1 0 1 1, because those are not going to use in BCD. Only the maximum one is this one. But if there is a 4-bit, we can represent 16 numbers or else 16 symbols. Okay, that is the thing. Okay, let's write. Right? Just put the topic BCD or else binary coded decimal. Binary coded decimal. BCD. Okay, first point. If I am too fast, just tell me. Okay, first point. Each digit is each digit is each digit is represented by 4 bits. Each digit is represented by 4 bits. This can create, next point, this can create, or else, yes, right. This can create a maximum of 16 symbols. This can create or represent maximum of 16 symbols. 16 symbols. Write this one inside the bracket. 4 to the power 4 equal 16. Okay. Next point. It is used only for representing decimal numbers. It is used only for representing decimal numbers. Decimal numbers. Okay, the last point. This was a coding system. This was a coding system used in early days. This was a coding system used in early days. We have used this one in early days, but in nowadays we are not going to use this one. Binary coded decimal. Okay. So then just write this one. Okay. Write 120. No, first write this one. Write this one and then this one. And also write the BCD code for 431. Good. This one also. 542. Right, for both two numbers. Just remember, we have to represent using 4 bits. Okay, every number or every symbol should be represented using 4 bits. Okay. Finish or good? Let's write. So 431. So 4 should be 0, 1, 0, 0. 3 should be 0, 0, 1, 1. 1 should be 0, 0, 0, 1. This is the BCD code for 431. And 542, 5 should be 0, 1, 0, 1. And 4 should be 0, 1, 0, 0. 2, 0, 0, 1, 0. That is for 542. Correct? Okay, no? Okay. Let's check. Okay. Good. So don't keep spaces. Okay. Don't keep spaces for each character. You have to just write all together. Don't keep spaces. That is about the first coding system. Very easy. Okay. I told you very easy. So the thing is, we can represent only numbers. Okay. Using BCD, we can represent only numbers, and one number or else one character should be represented using 4 bits. That is the only thing. Okay. And the maximum characters are 16. Okay. Okay. So let's move to the second one. ASCII. Okay. ASCII. I'm going to just write ASCII. ASCII. Okay. I'm not going to write the whole name. Second one. ASCII. We have written the whole name in the previous stage. ASCII. Okay. In ASCII coding system, we can represent what? Not only numbers, we can represent characters also. Okay. Characters and symbols. Okay. In ASCII, when we are using ASCII, we can represent 0 to 9. Those are the numbers. Okay. We can represent numbers. And then we can represent capital A to Z. Okay. Capital A to Z. And also we can represent simple A to Z. Simple Z. And also several characters like at, signs, hash, this one like oh my god mark. Okay. This is like oh my god. Single කියන බුදු අම්මෝ mark එක කියලා කියනවා. This one. Likewise, guys, there are several characters we can represent using ASCII coding system. Okay. So the next thing is, when we are using ASCII coding system, for one symbol, we are going to use, okay, one symbol, we are going to use 7 bits. Okay. In the previous case, for one symbol, we have used 4 bits. Okay, 4 bits. So in this ASCII, for one symbol, we are going to use 7 bits. Okay. That means what will be the maximum characters? maximum symbol. Maximum symbols can be represented using ASCII is 2 to the power 7. Okay, 2 to the power 7. 128 symbols can be represented by using ASCII. Okay. In the previous case, we can only represent 16 characters, 16 symbols. But here we can represent 128. Inside this 128 symbol, we have 0 to 9. That means there are 10. Okay, there are 10 symbols. Capital A to Z, we have 26. No, 26, no? Yes. Simple A to Z also, we have 26. And here we can just, so here let's calculate this one. So here we have 5, 6. Okay. 62 characters inside these three. Likewise, there are several other characters. Altogether, we can represent 128 characters using this ASCII code. Okay. Okay. Got it? Okay, no? Okay, answer? Yes, good. Good. Just answer. Okay. It is more easy, no? It is easy. So let's see. I'm going to represent capital A. Okay. I'm going to write the value of symbol A. So symbol A can be represented using seven bits. No? So A is like this. Okay. Capital A. Okay. Capital A like this. Okay. So capital B. Capital B is like this. Okay. Likewise, for each and every symbol, we are going to use one binary code. Okay. So in this case, guys, can you remember this one? Is it easy when we write this one? It is hard, no? A little bit hard. If you are asking what is the symbol of A, it is hard to remember this one. It is hard. So in that case, we are going to use a decimal number to memorize. So to memorize each value, we are going to use decimal number. So the decimal number is here 65. Okay, 65 is the decimal number. This is easy to remember. No? This is easy to remember. So when we talk about the ASCII code for A, we are just telling A is represented by 65. Okay? We are just going to tell A is represented by 65, but 65 is the decimal number. Okay? The actual code is in binary value. So that means we have to convert this decimal into binary to show the actual code. Okay, got it? Okay, this is for the just memorize. So this is for memorize. So then, when we talk about A, B, C, likewise the capital numbers. Okay, so A is represented by 65. So then B is represented by 66. Okay, C is represented by 67. Likewise, guys. So we are going to represent the other English letters, capital letters in this order. A will be started by 65 and the B should be 66. C should be 67 likewise. D will be 68 likewise. Okay. So the value will be like this. Okay, that means we are going to add one value and it is the next English letter. Okay, got it? This is about the capital letters. Okay, so if I write the code also, uh, one. Okay. D is like 1000100. So you can just convert this one. Okay? If you convert 65 into binary, the value will be like this. Okay? I'm not going to convert that one. Let's do a question and let's see. 67 and this is 68. This is about capital letters. So this will go to round Z. Okay. So you can just add 26 for 65 and value will be what? 6189. 91 is for Z. Okay, 91 is for Z. So then you can just convert and get the code. And capital letters will be finished from 91. Okay. Then simple letters will be start. But simple letters won't start by 92. Okay. Simple A is represented by 97, guy. 97. Okay. Let's see what is the binary value. Let's see the binary value. 97. I'm going to just divide. So here 4, 16 by 8, 240. And here 1, 2, 0, 6, 0, 3, 0, 1, 1. So the value will be 1, 1, 0, 0, 0, 0, 1. Okay, that is the value. I'm going to just erase this one. This is the value for simple A. Okay, simple A. Simple B is 98. Okay, simple B is 98. 98 means, so we have to just add another 1. 1, 1, 0, 0, 0, 1, 0. This is 98. Okay. This is about simple English letters. This is about capital English letters. Can you see the difference? Is there any connection between these two? Capital A and simple A? Is there any connection? Can you see that one? Can you see that one? So in the capital A, we have 1, 0, 0, 0, 0, 0, 1. Okay. In simple A, we have 1, 1, 0, 0, 0, 0, 1. In capital B, we have 1, 0, 0, 0, 0, 1, 0. In capital simple B, we have 1, 1, 0, 0, 0, 1, 0. You can see the connection. Only the second bit is inverted to 1. When we talk about capital, here we have 0. In symbol, here we have 1. Other things are same, no? Can you see that one? Can you see that one? Right? That is like coding system, guys. Right? That is like coding system. So they they didn't put 97 as their own. Okay? It is like a what? A connection, no? It is like a connection. Okay. So this is about the ASCII code. ASCII. Okay. The thing is, when we when we are going to use ASCII code, we are going to remember A as 65. Okay, but when we are write the code, we have to convert this 65 into binary, and you have to write the code. Okay, got that one? Is this okay? Hands up. Okay, good. So let's write. Let's write. Okay. Put the topic ASCII, American Standard Code for Information Interchange. American Standard Code for Information Interchange. Okay. First point. Each symbol is represented by 7 bits. Each symbol is represented by 7 bits. Okay. Each symbol is represented by 7 bits. Second point, this coordinate system can represent maximum of 128 symbols. This coding system can represent maximum of 128 symbols. Write this one in side bracket. 2 to the power 7 is equal to 128. 128. Okay. Next point. In addition to numbers, English letters, and various symbols. English letters and various symbols can be represented. Full stop. English letters and various symbols can be represented. Okay. So this number system was developed by, okay, don't write, okay. This ASCII, okay, this ASCII was developed by American National Standard Institute, okay. It is an institute. American National Standard Institute. Okay. So this American National Standard, we can say ANSI. So ANSI organization is the one who developed this ASCII code. Okay. Let's write that one. This ASCII code system, was developed by ANSI, or as right? Inside the bracket, American National Standard Institute by ANSI. American National Standard Institute. Okay. American National Standard Institute. Then next point, uh, write symbols. Just write symbols and then write this thing 0 to 9, A to Z, simple A to Z, and several symbols. Okay. Here you can write question mark, question mark, at mark, likewise. There are several symbols, several characters. And also space is another character. Space. Space is another character. Okay. Then write this one also, these two also. Write these two also. Raise your hand once you finish it. Okay, good. Let's write a code. Let's write one code. What is the name? What we can write? Let's write for hello. Let's write for hello. Okay, hello is a little bit difficult, no? But okay, let's write for hello. Okay. So write the question. Write the question. Write the binary. Write the ASCII code. Write the ASCII code. Write the ASCII code for word. Write the ASCII code for word hello. Write the ASCII code for word hello. This is a little bit difficult, but it is okay. Let's write hello. Okay. So when you guys given a question like this, you will be given the numbers also. Capital A is represented by 65 and simple A is represented by 97. Likewise, these things are also given in the question. Okay, only capital A and simple A. Okay, so then you have to find the other things. Okay, you have to find the other thing. So hello. So when we write hello, what are the characters? We have H, capital H. We have simple E, simple L. We have twice simple L and O. Those are the characters we have. H, E, L, O. Okay, those are the characters. So first of all, we have to figure out what is the decimal number. Okay, what is the decimal number? So let's write. So A, B, C, D, E, F, G, H. This is the H. Okay. A is 65, 66, 67, 68, 69, 70, 71, 72. H is represented by 72. Okay, got it. Okay. Likewise, we have to find out the other things also. Okay. Let's see. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. That's enough. A is 97, 98, 99, 100, 101, 102, 103, 104, 5, 6, 7, 8, 9, 10, 11. Okay, so a little bit difficult. Okay, E means 101, then L means 108, O means 111. Okay, so the first step is to figure out the decimal number. Okay, so then we can just convert that one into binary. Then we can just convert that one into binary. I have cleaned this one because I don't have space. So, but when you write the answers, you have to just write that one also. So let's write H. Okay. H is 72. So you have to just divide. 0, 0, so 1. Yes, do with me. Yes, start and do with me. So I think you got the procedure, the next part. Okay. I think you got the procedure. You have to just get the values for each and everyone, and you have to write in the same order. No? In the previous case, like in the BCD, we have to figure out the binary code for H72, and we have to write that one in the front, and we have to figure out 101, and then we have to write that one also. Okay. Good. You have already finished, no? Good. Very good. So, how did you convert this one? Did you use calculator or something? Or else just this method? You have to use this method, right? Because actually you don't have allow the calculators in the what exam. So here 1, 2, 3, 4, 5, 6, 7. What is a mistake? 66. It should can't be 66. It should be so I have mistake. No. Good. Divide. Good. 72, 36, sorry, not 66. One, two, three, four, five, six, seven. This one. So H is like 1, 0, 0, 1, 0, 0, 0. This is like H. Okay. E 101. E is like, I'm going to write in I will just keep one line, okay, to differentiate electron. 101, 1, 1, 0, 0, 1, 0, 1. This is E. Okay. So then L 108. L mean 1, 1, 0, 1, 1, 0, 0. This is L, but we have two L's. That means we have to repeat this one again. 1, 1, 0, 1, 1, 0, 0. This is again L. At last, we have O. O means 111. One, 1, 0, 1, 1, 1, 1. This is O. Okay. This is the last one. Okay. Just don't write these lines. Just don't draw these lines. So the ASCII code will be like this. Is this correct? Okay, no, just check whether it is so. This is the one. Is this okay? Just write this one. Okay, good. Jumit, just write this one. Okay, no, good. Okay, I'm going to erase this one. So actually, in the exams, you will not have a question like this. Okay, this is for understanding. So actually, in the exam, you will have a question like this. Sorry. So it is like if A is represented by 65, okay, if A is represented by 65, what is the ASCII code for E? Okay, likewise that. You will have a question likewise this. If A is represented by 65, what is the ASCII code for E? So then the same procedure. No? First, you have to figure out what is the decimal number for E. It is like 65, A, B, C, D, E. So then 70, no? 70. So you have to figure out 70 is the decimal number. So then you have to convert that 70 into binary. That will be the ASCII code. Okay. Likewise, you will have 69. Oh, okay, 69. A, B, C, D, E. 65. Yeah. Yes. 69. Okay. Yes, A is 65. Okay. Likewise, you will have a question like that. And also you will have a question like this. If D is represented by 1 0 0 0 0 1 0 like this, okay, I don't know, this is not the real one. What is the no, I will just write this A. If A is represented by no B B B. If B is represented by like this, what is the symbol of this? What is the symbol of this? Okay. Likewise, you will have a question. Let's write those questions. Okay. First, second question. Second question. Right? If A is represented by 65, if A is represented by 65, if A is represented by 65, what is the ASCII code for capital E? If A is represented by 65, what is the ASCII code for capital E? Capital E. Okay. Next question. Third question. Third question. If B is represented by this one, if B is represented by, then write this as code. If B is represented by this code, comma, what is the character? What is the character represented by this code? Code. Let's write the code. What is the character represented by this one? Okay. Likewise, you will have a question in O-level, right? In O-level exam. I'm focusing on O-level exam. Okay? You will have a sure MCQ question. You have to just write the answers. Okay. Not now. Those are the homeworks. Let's write for number. All right. Let's write ASCII code for number. 42. Okay. Fourth question. Fourth question. Right. Write the ASCII code for number 42. Write the ASCII code. Write the ASCII code for number 42. Write the ASCII code for number 42. inside the symbol, inside the bracket, just write 0 is equal to 48. That means 0 will be represented by 48. Okay, 0 will be represented by 48. So then 0, 1, 2, 3, 4, 48, 49, 50, 51, 52. So that means 50 and 52. Only 6, no? When we write 52, only 1, 2, 3, 4, 5, 6. That means we have to use 7. That means in the front, we have to use 0. In the front, we have to use 0. So that means 4. 4 will be represented by 0, 1, 1, 0, 0, 1, 0. This is 4. Is this correct, no? Yes. 2. Okay. So this is 2, no? This is number 2. Sorry, my mistake. This is number 2. Okay? So let's see number 4. 1, 2, 3, 4, 5, 6. Here again 6. So we have to write 0, 1, 1, 0, 1, 0, 0. This is 4, and for 2, 1. So we have to just write 0, 1, 1, 0, 0, 1, 0. This is for 42. Okay. Is that okay? Okay, no? Right. So once again, I am telling you, you will have an exact question in this ASCII coding system. Okay, ASCII coding system. Okay. Write this one, and let's move to the next coding system. Do that two homeworks. Once you finish, just raise the hand. Over. What about the POE day? In next week, we will have the Poson POE. You may thought about you. Are you going to go to Dansal? Or is it Dansal Kandianwal? Or just stay at home? Good. No. What about Altaf? Are you guys go for yesterday you had what is the festival yesterday you had? Hajj, you know? Hajj? Oh, Hajji. I don't know actually. Hajj. Hajj. So that is mean it's like a new year or something. Or is what is the meaning of that? Actually, I don't know. Is that the birth date of your god or something? I don't know actually. What is the meaning? I don't know. Oh, still typing. New year. Okay. So happy Hajj, not Hajj, we are telling like happy Eid Mubarak or like this. That no. Yes. Okay. So do you guys visit to the dancers or something? So in the Tuesday, we have the perform poetry. So in that day, there are several dancers. That mean I don't know English name. Okay. Yes, good. Okay, good. Just talk with your friends and just go with your friends or just family. Okay? It is better to go with your family because there are several accidents. Okay, I seen today also there are several accidents, and also just don't go swimming for the lakes. Okay, there are several lakes in our country. You know that one. So don't go to swim to those lakes because I have seen there are 4 people just died from drowning. Okay. They have just drowned and they had died. 4 people. Okay. So likewise, just be careful. Okay. Be careful. Don't go to swim and just be careful when you are going on the road also. Okay? Because there are several drivers. They just don't care. Okay. There are several drivers. They just don't care. They are just driving. Okay? So if you are going in the right side in the road, they just don't care. They're just driving and they will hit you. Okay. So be careful when you are just walking beside the road. Okay. And also when you are just uh, going in a bus or something. Okay. Just be careful when you walking. Okay. Just make sure there are no any dangerous area or something. Just don't look at your phone and walk in the road. Okay. That is a very dangerous one. Okay. So be careful, okay? In the possum poetry, actually. Okay, so let's move to the next one. So we have 2 coding systems. So actually, guys, in the other 2 coding systems, we don't have questions. Questions means we don't have calculations. Okay? We don't have calculations. We have to just remember the number of bits and the number of symbols. Very easy. Okay. For the previous 2 coding system, we had several conversions, no? Conversion like that. But in the other 2, we don't have that much. You have to just remember the number of bits. Let's see the next one. EBCD IC. It is like extended binary coded decimal interchange code. Okay. Extended binary coded decimal interchange code. That means this is an extended version of binary coded decimal. Okay, this is an extended version of binary coded decimal. But in this coding system, we are going to represent all the symbols and all the characters, not only the numbers. Okay, the binary coded decimal, we represented only the numbers, no. But here, we are going to represent the English letters also. Okay, so the thing is, in this coding system, for one symbol, we are going to use 8 bits. Okay, we are going to use 8 bits. And what will be the maximum number of symbols. Maximum number of symbols, you know how to calculate. 2 to the power 8. It is like 256. We can represent 256 symbols using extended binary coded decimal. Okay, extended binary coded decimal. So this coding system was used in IBM computers. Okay, IBM mainframe computers. This coding system used. Okay. Okay. This is about the ABCD IC. Let's write this up. Okay. Just write the topic ABCD IC. Okay. Or else extended binary coded decimal interchange code. So actually we have write that one previously. That's why I'm not going to write that one in here. Okay, because we have wrote that one earlier. Okay, so just write ABCD IC. Okay. If you want to write the whole name, just write extended binary coded decimal interchange code. Okay. Okay. Let's write. Okay. First point. Each symbol is represented by 8 bits. Each symbol is represented by 8 bits. 8 bits. This coding system, next point. Okay, next point. This coding system can represent maximum of 256 symbols. Maximum of 256 symbols. Write this one inside the bracket. 2 to the power 8 is equal to 256. 256. Okay. Next point. This code system was used in IBM mainframe computers. IBM mainframe computers. This code system was used in IBM mainframe computers. Okay. That is about ABCD IC. Okay. Extended binary coded decimal interchange code. That is all about this. Okay. So far we have learned 3 coding systems. Okay. In the first coding system, we could write 16 symbols, no? In the first coding system. And in the second coding system, we can write 128. This one we can represent 256. Okay. When using ABCDIC, we can represent only 256 symbols, guys. Okay. But you know, nowadays there are more than 256 symbols, no? When we talk about different languages, okay, here actually they can represent only English letters, no? In the ASCII code also, we can represent only capital A to capital Z and also simple A to simple Z, no? only English numbers, English words. Here also, we can represent only English words. But you know now, we have several languages. No, we have several languages. So when we talk about Sinhala, Sinhala is another language. So inside Sinhala language, I think there are several several symbols. I don't know. I don't know the number value. Here තියෙනවා සිංහල වල 120. I don't know. I don't know actually. So let's see. In Sinhala, we have 120. Let's see. I don't know. This is not the exact number. Okay, I just wrote this one. And in English, you know, altogether we have 52. Okay, Sinhala, sorry, capital and simple. Okay, and also English, Tamil. No, we have Tamil language also. Tamil, I don't know actual number. Okay, 100. Okay, just right now 100. And what is your language, Altaf? What is the name of the language? It is Arabic, no? I don't know the name Arabic, no? I think Arabic. I will go in it's Arabic. In Arabic, how many symbols? Do you know in Arabic? How many symbols? I don't know actually. Let's say 100, 120. I don't know. Like here also we have more than 256. Okay, and we have Korean. Okay, Korean. We have China. Okay, like several languages. Okay, so that means this one is not enough. Only using 8 bits is not enough. Okay, that's why we have developed a new coding system which is Unicode. Unicode. Okay. Unicode is the last one. In Unicode, guys, Unicode, one symbol is represented by how many bits? How many bits? 16 bits. Okay. In Unicode, one symbol is represented by 16 bits. Okay. That means maximum symbols are 2 to the power 60 is equal to 65,536 as I remember. Okay, we can represent 65,536 symbols using Unicode. Okay, a huge number, no? Huge number. Here actually we had only 256, but here we have 65,000. Very huge. So inside that 65,000, we have English, Sinhala, Tamil, Arabic, all the languages, and also we have all the numbers, all the symbols, okay. All the things are inside in this 65,536, and it is also more than enough, no? It is also more than enough. So in that case, they have included several flowers also. Okay, not only what languages and also the numbers, but also we can represent several flowers and trees. Okay, I think you know there are several fonts. No, there are several fonts. We can just type flowers. There are several fonts. We can just write the flowers or else, and also the emojis are also using several symbols. So just to know if we like if we type just this symbol and this symbol, okay, so then this will create an emoji like this. Okay, likewise, the emoji have a one symbol, several symbols. So, this is the Unicode. Okay, Unicode was created because we have several languages and we have to represent several symbols. So in that case, we have developed the Unicode. In Unicode, one symbol is represented by 16 bits. Okay. So also, guys, we can use Unicode for several to represent several what images and also several things. So, and most of the case, several newspapers and also the other web pages. Okay. So nowadays, web pages and also newspapers are coded using Unicode. Okay. Using Unicode because inside the Unicode we have several languages. No? So web pages can be represented using several languages. This is about the Unicode. Okay, this is about Unicode. So the thing is, we can actually represent graph. We can also represent graph and audio using this Unicode. Okay. So as example, let's see a graph. If we have a graph like this, okay, so we can use values, Unicode values for each point like this. Okay, like this, guys, audio wave or else yes, audio waveform also like this graph. Okay, that is about Unicode. Okay, let's write. Let's write. Next topic, Unicode. Unicode. Right. This is the coding system. This is the coding system. This is the coding system used today. This is the coding system used today. This is the coding system used today. Next point. Each symbol is represented by each symbol is represented by 16 bits. Each symbol is represented by 16 bits. Okay. Next point. This coding system can represent maximum of 65,536 symbols. Maximum of 65,536 symbols. Write this one inside the bracket. 16 to 2 to the power 16 is equal to 65,536. Okay. Next point. In addition, Unicode can be used to Unicode can be used to, in addition, Unicode can be used to represent graphical and audio data. Unicode can be used to represent graphical and audio data. Graphical and audio data. Graphical and audio data. Okay. Which means, sorry, don't write. Okay, don't write. Which means, guys, graphical. Graphical means an image or a picture. Okay. We can represent a picture using the Unicode. Okay. What is the method? You know, when we draw a picture or else when there is an image is consisting several colors, no? Colors. Image is consisting several colors. So we are going to represent each color using one Unicode, one code. Okay, likewise. That's why we are going to represent Unicodes. Sorry, graphics. Graph. Okay. And the next thing is there are two organizations for this one. As in the Unicode, as in the ASCII, we had ANSI. Okay. Likewise, for Unicode also, there are two organizations. That's right. Last point. There are two organizations for this. There are two organizations for this. There are two organizations for this. International Standard Institute, first one. International Standard Institute. Okay, this is the first one. And the second one is Unicode Consortium. Unicode Consortium. Unicode Consortium. Unicode Consortium. International Standard Institute. And the second one is Unicode Consortium. Okay. Last point. Okay, last point. This is the last point. This is the last point. Unicode is widely used for. Unicode is widely used for. Unicode is widely used for creating websites and newspapers. Unicode is widely used for creating websites and newspapers. Okay, that's all. That's all about the coding system. Okay, there are 4 coding systems: BCD, ASCII, EBCDIC, and the Unicode. Okay, those are the 4 coding systems. And there is a small part remaining in this lesson. Okay, that is the what we have to just get the knowledge about the data representation. Okay, that's been kilobyte, byte, megabyte. Likewise, there are several capacity. So we have to just get the knowledge about those things. Okay, data storage capacity. So we will continue that one in the next day, and also we can start our next lesson also in the next day, next week. Okay. Okay. So let's conclude our session. Okay. So let's meet on the next week, and also stay safe, as I told you earlier. Stay safe, and when you go out, just be careful. Okay? Just be careful and just be in a very careful. Okay? Just careful. Okay. Okay. So let's conclude. So goodbye, guys. So see you next week. Okay.